So now we've found that we can extend the cosine function throughout the entire complex plane. So the next natural question involves, well, what the heck is cosine of A plus IB? Well, let's see here. This is going to be e to the I A plus IB plus e to the minus I A plus IB divided by 2. All right? So that's going to be e to the IA times e to the minus B plus e to the minus IA times e to the plus B, all divided by 2. Now, it turns out that we can simplify this and write it in terms of the cosine and sine functions of real numbers in conjunction with some new functions. So if I were to expand e to the IA as cosine A plus I sine A, e to the minus IA as cosine A minus I sine A, we see that the cosine terms come together. So it's going to be cosine A, and then it's going to be e to the minus B plus e to the B, so that's e to the B minus e to the minus B over 2, and then it's going to be plus I sine A, all right? And actually, I'm going to make it minus I sine A, and then it's going to be e to the B minus e to the minus B all over 2. And so these look just like, oh, so this should be plus. These look just like the definitions that we had for cosine and sine, except they're missing the i's. All right? That causes their relationship to no longer be dude squared plus other dude squared equals 1, because we don't have that I here. All right, so it turns out that these functions are going to satisfy dude squared minus other dude squared equals 1. Now, while the equation of a circle is x squared plus y squared equals 1, and so the sine and cosine functions can be thought of as circular trigonometric functions. They live on the unit circle. These new functions live on a hyperbola. And so that for that reason, they're called the hyperbolic trigonometric functions, or just hyperbolic functions. All right, cosh B, the hyperbolic cosine, so that's going to be e to the z plus e to the minus z over 2, and the hyperbolic sine, sinh z, e to the z minus e to the minus z, all divided by 2. These can be thought of as the even and odd parts of the exponential function. We will also extend them to define the tanh function and other related functions like sech, the hyperbolic secant, cosech, the hyperbolic cosecant, and coch, the hyperbolic cotangent. Those are going to come up in unexpected places later on.